All right, so we're going to be talking about Unit 1, Lesson 2, which is we're going to be talking a little bit about segments and distant formulas, okay? So your learning targets, you're going to state the definition of a point, a line, and a plane. You're going to describe the properties of segment congruence. You're going to use the distance formula and midpoint formula in the coordinate plane. And you're going to be able to explain the concept of equidistant and provide examples in the coordinate plane. So here we've got our segment measures. Now, here's our coordinate point number that is identified at the specific point. So here we've got A. So the coordinate of A is a -3. The coordinate of E is 5. And that's what's called a coordinate point. It's just the point at where whatever E is at, the coordinate point is going to be 5. If I said, what coordinate is 5 at, you would say E. Okay, so the measure of A and B is the distance or the length from A to B. Now, what is the distance of A and B? So we're just going to go ahead and count the marks. So the distance from A to B is 1, 2, and you actually don't count this first one, so it's actually 1, 2. Now we're going to go ahead and do it mathematically. So AB equals A minus B. So let's go ahead and do that on paint. Okay, so A was -3. So a -3 and B was a -1. So -3 minus a -1. Now a negative and a negative make a positive. So this is a -3 plus a -1, which is, so a negative and a negative, makes a positive. So a -3 plus 1 is a -2. So it's 2 distances away. Just what we said, 1 and 2. Okay, now it says determine the measure of BF, so here we go, B to F and F to A. Use the coordinate plot below. So let's figure it out. We've got B and F, so B to F, a -1 minus 7. So let's do that on our sheet here. So coordinate B is at a -1 and coordinate F is 7. So -1 minus 7. So a -1 minus 7. Now a negative and a negative makes a positive, and we add our negative. So it's going to be -8. So if we count, it should be 8 distances away. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. We are correct. So let's see if we went from F all the way back to A. So you always start with the number first. So it's going to be 7 minus a -3. So let's go ahead and write that out. So 7 minus a -3. And again, a negative and a negative make a positive. So we've got 7 plus 3, which is 10. So let's go ahead and count. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we are correct. So now what I want you to do is I want you to go ahead and do segment measure. Go ahead and do example 3, 4, and 5 on a separate sheet of paper, and I will go ahead and collect that on Tuesday. Okay? So now we're going to go ahead and deal with segment addition here. So we've got AB plus BC equals AC. So that's very simple. A and B is 5, so 5 plus B and C, which is 3, equals 8. So then AC must equal 8. So A and C, which we already said was 8, plus B and D, so we've got 3 plus 3. So 8 plus 6 equals 14, which is what A and D equal. So from A to D. Okay, so now we're going to look at BC, which is 3, plus CD, which is 6, equals BD. So from B to D is 6. So that's the segment addition. So go ahead and do, it says AB, the segment addition property. So AB plus BC equals all of A and C, if and only if points A, B, and C are collinear. And we know from lesson 1 that collinear means that all of these points have to be on the same line. So the measure of A and B plus B and C is going to equal A and C, or AC. So AC equals 10. So it says over here we've got segment addition. So we are given that A and E, so this entire line of AE, equals 21. And they also say that AG and GF and FE, they're all equal to each other. So what we can do is we can say, well, there's 3 different lines, and the entire thing is 21, so we can just divide that by 3. So let's go ahead and do that. 21 divided by 3. So 3 divided by 21 is 7. So each of these lines, AG, GF, and FE, have to equal 7. So let's look here. A and C, the whole line equals 15. And if AB is 8, well then all we have to do is say, all right, so A and C, the entire thing is 15. If this is 8, then 15 minus 8 has to equal BC. So let's do that. 15 minus 8 is 7. So line BC has to equal 7. All right, so now we do examples. So now I want you to go ahead and do this example on your own. Again, I will be collecting that on Tuesday. So let's go down to the distant formula. Now the distance formula is where there's 4 quadrants here, and it's when we are looking to find the distance or the length between 2 points in a coordinate plane. We would use the distance formula. So if I want to know the distance between, so let's go over here actually, and let's look at this example. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So here are our 2 x's and y's. So let's go ahead and let's draw out our formula. So the distance formula, let's use a D for distance, equals the square root, okay, of x2 minus x1 squared plus y2 minus y1 squared. All right, so let's see what they give us for our x and y. So our x and y for the first pair is 1 and 1 and 4 and 5. So let's go ahead and do that. So A is 1, 1. Okay. And then B is 4 and 5. So 4 and 5. All right, so So let's go ahead and plug that in. So x2 is actually going to be this x2. So it's going to be 4. So the square root of 4 minus x1, which is 1. So minus 1 squared plus y2, which is 5, minus y1, which is 1, minus 1 squared. So 4 minus 1 is 3. So 3, got to keep our square root. So 3 squared plus, close that, plus 5 minus 1, which is 4, squared. So let's go ahead and switch colors. So that's going to equal 3 squared is 9, which is just simply 3 times 3. So 3 times 3 is actually just 9. So 9 plus 4 times 4, which is 16. Okay? So 9 plus 16 is actually 25. So the square root of 25 is simply 5. So the distance between points 1 and 1 and 4 and 5 is 5. That is your distance. Okay? So now we're going to talk a little bit about congruent segments. Now a congruent segment is something that is, congruent is something that is the same shape and the same length. So congruent segments are segments that have the same length. So the symbol for congruent that we use is an equal sign. So this sign right here is used to say equals. So that means it's congruent and it's also equal. Okay? And here we've got example 1. Are the two segments congruent? So the measure of AE is 20 and then the measure of AG is 20. So they're the same length, which means they are congruent. They are the same. So now over here, using the distance formula, we're going to find the length of BA, AC, and AD. And we're going to see if any of those are congruent to each other. So let's go ahead and try that. So let's go ahead and draw out our distance formula. Now remember, our distance formula is x2 minus x1 squared plus y2 minus y1 squared. All right, so let's change colors. Let's go ahead and first let's find BA. So B is a -4. So B is a -4, comma, 3. And A is -1, 1. So -1, comma, 1. So let's go ahead and plug those in. We're actually going to run out of time. So go ahead and plug these in for me. And go ahead and continue with C and A and D and A. Then you're going to compare them to see if any of them are congruent. That is also due on Tuesday.